problem 902 number at most n given digit set. So for this example, we are giving a digit set, so it is an array, and inside it's gonna be some string. So for example, it's gonna be the digit like 1, 3, 5, and 6. Yeah, so which is sorted in non-decreasing order, and you can write numbers using each digit I as many times as we want. So for example, we have digit 135, so we may write numbers such as 13 or 551. So for each of the digits, we can repeat many times. So this is what we are giving, and we can also write like 135, 131, and 5. Yeah. So we're gonna return the number of positive integers that can be generated that are less than or equal to a given digit n. Yeah. So what we are doing, we are giving this digit n. So for example, currently it is 100, and for each of the digits, we can use many times. So currently we have 1, 3, 5, and 7. So for example, what if we only have 1? So what's gonna happen? Yeah. Because we're gonna return the number of positive integers, yeah, which are less than or equal to a given digit n. Yeah. So can we choose like 1 from this position? We cannot, because if we choose a 1, we have to choose 0, 0, but there's no 0 inside. Definitely it is not possible. Yeah. But what we can do, so at this place we cannot choose anything. So what about at this digit? Can we choose a number? Yeah, so let's just try to choose a number. Maybe we don't want to choose any number, and then we have to choose this digit. So there's no digit in this position, and then for this digit we might choose a number like 1, 3, 5, or 7. So it can be 1, 5, 3, or 7. Yeah. So this is a no digit. So what happens if there is a digit? So for example, there's the digit 1. This is also possible. Yeah. So after this 1, what kind of digit we can choose? So we can still choose 1, 5, 3, 7. It is also okay. Yeah, for our problem. So this means it's gonna be a digit DP problem. There can be many templates to write the digit DP, but at least you should know one template. Yeah, because the template is gonna be the easiest way to use to solve the problem. Yeah, basically this is the digit DP. This means for each of the digits we need to control a lower and higher number. Yeah, but for us, we just need to use control the higher number, because we need to find all the numbers which gonna be less than and equal to 100. Yeah, so this is what we are doing, and what we are giving is all those digits. We can use 1, 3, 5, and 7, and we cannot use others. So this is exactly the digit DP. Yeah. Yeah, now let's just try to solve it. Yeah, because for digit DP, normally the time complexity gonna be really small. Yeah, but let's just try to write the digit DP. After that, we're gonna analyze the time complexity. Yeah, so we're gonna use I. So it's gonna be the first index, index 0, and then I don't need to use a mask because there's no distinct integers. We just need to control. We just need to choose the different numbers which is gonna be less than or equal to 100. So there's no mask, and we're gonna use its limit. Yeah. So this means for each of the position we're gonna choose its limit. So for example, current number is 100. So we're gonna have a limit of 1. So currently this person can choose a 1 because this is the limit. Can we choose 2? No, we cannot choose because the maximum number we can choose at this person is 1. Yeah, so this is why we're going to use its limit. Yeah, so for example, if we don't want to choose any number, so there's no number. So what's going to be this position? Yeah, so it can be any numbers. Yeah, but what's going to be the limit? The limit is going to be 9. Yeah, because the biggest number we can choose is 9. Yeah, but for currently we can choose a 9. It is okay. But whatever number actually it is a 7. 1, 3, 5, 7, because all those numbers are going to be less than and equal to 9. So that is okay. Yeah. So this is what we are doing. And also we need to prepare another variable or parameters. We're going to call its number. So this is for preparing the previous digit. Yeah. So this its limit is also for the previous digit. We just want to check while we are checking this digit, we're gonna check the previous digit, is it a limit or not. And currently, if we are going to check this digit, we are also going to check the previous digit, is there a number or not. If there's no number like this one, we can choose 1 to 9. But if there's a number 1, definitely we cannot choose anything because there's no 0 inside. Yeah. Now let's just start. So first of all, let's just turn this n into a string. So this is normally what we are doing for digit dp. Yeah. So we're gonna choose if I equal to the length of the string. So this is n. So this is a string n. Yeah. So we're gonna check this I. If this I equal to the length of the string, so normally what we can do, yeah, we can return the integer of its num. So this means if this its num is true, we're gonna return a 1. If it is false, we're gonna return a 0. Yeah. So this means for the previous one, if this is a number, so definitely we're gonna return true. But if this is not number, we are doing something but there's nothing inside, so definitely we're gonna return a 0. Now we're gonna prepare a result, and for the template we're gonna check this is num. If not is num, so this means so previously if it is not a number, so the result is gonna equal to the fi plus 1 with a false and false, because we didn't choose as any number, so the is num gonna be false, and the is limit also gonna be false because we didn't choose anything. So for example, this 100, at this place we didn't choose anything. This means it's gonna be false for the limit. So this means for the numbers, if it is a false, definitely for the numbers we can choose anything from 1 to 9. Yeah, anything from 1 to 9. Yeah. Now we're gonna prepare a high, as we are only need to control the highest number. We don't need to control the lowest number because we want to check all the numbers which gonna be less than or equal to n. Yeah. So the high gonna be the integer. Yeah. Currently we don't need to use this integer because we can also use the string to compare if this is bigger or smaller, because the string 1 is smaller than string 3. Yeah. So we're gonna use si. So high is gonna equal to si if it is a limit. Otherwise, so we're gonna choose the string 9. Yeah. Now we want to check all the digits. So for digit inside the digits, and we want to check. Yeah, we want to check this digit. So if this digit, current digit, is more than the highest digit. So here is the highest digit. If it is more than the highest digit, basically we're going to control it as 100. But if it is more than that, so for example, this is 1, but if it is a 2 or something else, if it is more than that, so definitely we're going to make a break. Yeah. So this means for this digit, yeah. So first of all, for this digit, so if it is too big, definitely we will ignore it. So this is why we're going to use a break. So first of all, if we are going to use this digit, definitely we're going to break it. Yeah. So this means even maybe we can only choose a 1. Yeah. So the highest digit may be 1. Maybe we can only choose 1. Yeah. But after that, definitely we cannot choose anything. This means it is not finished. Yeah. Now, what we can do, if it is more than the highest digit, so we're gonna break it. Yeah. So otherwise, we're gonna update it to the result. So it's gonna be f with I plus 1, and for this is the limit. Let me think about it. So for this is limit, we're gonna set it to false, and for this is num, it's gonna be true, because definitely we're gonna choose a number, choose a digit, so we're gonna set it to true. Yeah, but for is limit, it is not false, it is limit, and yeah. So this is what we are doing because for this is limit from the beginning, we're gonna set this is limit to true. So this is why we're gonna always need this is limit to check. So for example, this is 100, and at this position is limited true. So here this is limited to true, and then we're gonna check this number. So from the beginning, it's gonna always be true. Yeah. Only if it is not equal to the highest digit. So for example, this is not equal to the highest digit, and then we're gonna set it to false. Yeah, so from the beginning, if this is the highest digit one, then it's gonna be true. Yeah. Yeah, and the condition is this digit gonna equal to the high. Yeah. So we want to choose set the is limit only this is limit is true and this digit equal to the highest digit, so we're gonna set it to true. Yeah. So finally, we're gonna return the result, and finally, we're gonna return this f function, and this dfs function, the is limit is gonna be true, and the is num gonna be false. Yeah. Yeah. Maybe this is very confusing, but this is exactly what we are doing for this problem. So if you already understand something about the DP template, how to write the template, normally you should understand how to, why we're gonna use this kind of code to write for this problem. Yeah. Now let me just run it. As you can see, it works. Now let me just submit it to check if it can pass. Yeah, as you can see, it's pretty fast and it passed for all testing cases. And the time complexity we can check it from here. So this is a 2 because this is a Boolean, and this is also Boolean. It is a true. And for this I, because for this I is less of this number, maybe this is only 10. Yeah. And there's a for loop, so this is a 4 because there's a 4 digit. Yeah. So this is going to be the time complexity 2 times 2 times 10 times 4. So that is why it's so small. Yeah. Let me just check the length of the digit. Yeah, so the number gonna be 10 to the power of 9, so this is why it is a 10. Yeah, so this I gonna be 10, this is 2, this is a 2, and this for loop is 4. Yeah, so this gonna be the time complexity. It is like less than, yeah, it is around 100. That is why it's so fast. Yeah. So the difficult part is from the beginning, we're gonna set this is limited to true. And from here, we're going to always check if this is limit is true and d equal to high. Yeah. So for example, let's just use let's just use 100 maybe. Yeah. So currently this is 100. So I equal to 0. So this is a string currently. And if I equal to 0, so what are we going to do? Yeah. So result equal to 0. If not num, so currently, yeah, this num is false. Yeah. So if it is a false, so currently this is num is we're gonna set it to false. Yeah. So this is why we can use it directly. If not is num, so this means we're gonna update the result. So the result gonna update to the next digit. So currently we're gonna not choose this one, and it will go to the next digit. It goes from here. Yeah, and it's gonna be this. It's gonna be this is limit gonna be the false, and the is num gonna be the false because here we didn't choose any number, and this false is the is what we are doing for the previous digit. So the previous digit is false. This means from here we didn't choose any digit, and then from here we're gonna choose something what we can do. Yeah. So of course, because here we didn't choose anything, so here we have 2 digits. So normally inside of the 2 digits, we're gonna have anything else. Yeah, because this is false, this is false. So normally we're gonna choose everything else. So here, after here, we're gonna still have 2 decisions. We can choose 1 digit or we can choose 2 digits. Yeah. So this is for 1 digit. We're gonna have 4 numbers, and this is for 2 digits. We're gonna have such other numbers. Yeah. So this is what we are doing for the DFS, recursive function. And another decision is that, so this is the result. Yeah. So after that, here we're gonna update this result. Maybe this result is 20. So currently, we calculated this result. Actually, it is 20. Yeah, we calculated and it is 20 from here, this result. But here we're gonna check this high si if it's limit. So from the beginning, this is limit is true. So this means the high gonna be si. So si gonna be on 1. So this is the high. Now we're gonna check the digit for all the digits inside of the digits array. So we're gonna check one by one. Yeah. So first of all, what about we just check this one? Yeah. So if it is more than digit, we're gonna break. So of course, 3, 5, and 7, we're gonna break it. So this means we will not doing anything about it, because if it is more than 1, definitely we're gonna break. But what if it is less than or equal to the high? What are we gonna do? So we're gonna update it to the result. So it's gonna be fi plus 1. So it's gonna be, this is I plus 1 gonna be here. And yeah, let's just check about this is digit. So its limit is true from the beginning, and this digit is 1, 3, 1. This high is also 3, 1. So this means this is gonna be true. Yeah, and here its num is also true. So this means previously we're gonna have this num 1. It is true, and its limit is also true, and we're gonna update it to the next one. Yeah. So from here, definitely we want to choose some numbers. Yeah. So this is the first pass, and this is the second pass from here. Yeah. So after this one, what are we gonna do? Because this its limit is true, and here this its num is true. Yeah. So what are we gonna do? Here this I gonna equal to 1, gonna be equal to this digit 0. Yeah. Currently I not equal to length of the string, so we're gonna continue, and this is the result. We're gonna set it to 0, and we're gonna continue to check. So if not is num, so currently its num is true, so definitely we will not go to this pass. Yeah, because here is a number, definitely we will not go to this pass, but we're gonna go to the second pass, which is gonna be high. Yeah, so high gonna be si if its limit. Yeah, so currently its limit is true, so this high gonna be 0. Yeah, so now the high gonna be 0. Yeah, for this digit, this high is 0. Yeah, so inside of the array, can we find any number which is gonna be more than 0? No, we cannot find. I'm sorry. So inside of the array, all those numbers like 1, 3, 5, 7, it will always be more than 0, right? Yeah, it will always be more than 0. So this means we will break it. So we will not do anything. We will not plus anything inside of the result. So the result gonna still be 20, because we cannot find. Yeah. Now we're gonna have another decision. So we're gonna choose it, not choose it. Maybe we don't want to choose it, and then let's just shift to the. Yeah, here we cannot. We have to choose it. But from here, we cannot choose any number. But for this branch, for this DFS, we have to choose a number, but we cannot choose any number. So we just break this branch. This means this is not possible. So we just break it, and our result gonna be 20. Yeah. So this is exactly what we are doing for the DFS with memorization for the digit DP. Yeah. I think that's all about it. Thank you for watching. See you next time.